Okay guys, we're gonna just do an intro to trig identities. Okay, so these are these crazy things where, oops, I spelled that wrong. Identities, where you're not solving. So you're not trying to find out what x equals. You're trying to prove a left side is equal to a right side by subbing in things that you already know. So we're going to prove a couple identities that you're going to use, and these identities are what you'll use to like sub into equations to prove other identities. So the first identity we're going to prove has to do with tan. So first I'm just going to remind you that instead of using sine theta equals opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta equals opposite over adjacent. Remember how we talked yesterday about an angle in standard position, initial arm, terminal arm, principal angle. We talked about instead of calling this side the opposite side, we are now going to refer to it as y because it represents y on this grid here. And instead of calling this guy the adjacent, we're now going to say x. And then we thought r would be a good word for this because it's kind of like the radius. If you turn this into like a unit circle, it's kind of like the radius of that circle. So we're now calling sine theta y over r, cos would be x over r, and tan would be y over x. So that's our new terminology. Instead of opposite, adjacent, and hypotenuse, we're doing the y, x, and r. Okay, so now I'm just going to show you what else we can call tan. So we're going to use this guy, and we notice that tan is equal to y over x. And I'm noticing that sine has a y in it and cos has an x in it. So we're going to make an identity here that for tan. Okay, so I'm going to isolate this equation for y. So I'm going to multiply both sides by r, which will give me r sine theta is equal to y. And this one will give me r cos theta is equal to x. So I've just isolated y and x. Now I'm going to sub them into this equation for tan. So I see that tan theta is equal to y over x. But now I know that y is actually r sine theta and x is actually r cos theta. So if I subbed that in, I've got r sine theta divided by r cos theta. And I can actually cancel out these r's because r divided by r would just be 1. So I've just proven that tan theta is equal to sine theta over cos theta. So this is actually a trig identity, that for all values of theta, no matter what the angle, tan theta will always be equal to sine theta divided by cos theta. So if you know sine and cos theta, then you can figure out tan theta. So this thing right here is called the quotient identity. So we're going to use this identity to prove other identities. So this guy, quotient identity, it's going to help us solve other identity or prove other identities. Okay, so that's our first identity. Next, we got one more here to prove. You will never have to prove these again. We're just going to prove them now, and then we can just use them forever. So our next identity involves this thing again. So remember we said there's our initial arm, terminal arm, principal angle. We know that if we want to find side r, we have to use the Pythagorean theorem. So we know that x squared plus y squared is equal to r squared. So that's our Pythagorean theorem. So if I randomly, I can do anything I want in an equation as long as I do it to both sides. So let's say I just divide everything by r squared every term. That's like a total random thing to do, but I'm doing it to try to prove an identity. So I'm dividing everything by r squared. Like, I know that's so weird, but you can do that. You can multiply everything by 5 if you wanted to. But I'm trying to create some identity that I can use to prove other identities. Okay, so I've divided everything by r squared. So what I notice here is those will cancel out and become 1. Whoops. So I know that will be equal to 1. This guy, x squared over r squared, I'm just going to rewrite it as x over r squared. And this other guy I'm going to rewrite as y over r squared, because that means the same thing. They're both squared anyways. And then one thing I'm noticing is, let me just scroll up here. I'm noticing that I know x over r is actually equal to cos theta, and y over r is actually equal to sine theta. So I'm going to replace x over r with cos theta, and I'm going to replace y over r with sine theta. So this is actually my next identity, although I'm going to rewrite it differently. So normally we don't write it like this, like cos theta squared. We actually write this as cos squared theta, but it actually means, like, this means, you know, cos theta times cos theta, or cos theta all squared. But the way that we write it is actually like this. That's like the proper way to write that. Okay, so I'm going to rewrite this as sine squared theta equals 1. So this right here is my next identity, and we call this the Pythagorean identity. So those are my two identities that I want to use all the time to solve other identities. And the one extra thing you should know about this identity is you can rearrange it. So it can be written as sine squared theta plus cos squared theta equals 1. You can also rearrange it so that it's like sine squared theta equals 1 minus cos squared theta, or cos squared theta equals 1 minus sine squared theta. Oops. So like these are all variations of the Pythagorean identity, and you'll need all of these to prove other identities. So we've got two identities, and those are basically the only two you learn in grade 11. You'll learn a whole bunch more in grade 12. But actually one other thing that I need to tell you about, it's not exactly an identity, but are these. These things are called the reciprocal trig ratios. Do you know how we were talking about the primary trig ratios, which are sine, cos, and tan? Well, there's actually reciprocal trig ratios. So sine theta is equal to, like, opposite over hypotenuse, or the new way to put it is y over r. So that's sine theta. So it turns out there's actually kind of like an opposite guy called cosecant theta, which is equal to 1 over sine theta. So this guy right here is called cosecant, and it's actually equal to 1 over sine theta. So it's the reciprocal of sine. And therefore, since it's the reciprocal of sine, it's like you flipped sine upside down, it's actually equal to the hypotenuse over the opposite, or r over y. So this is kind of another identity-ish, it's not really an identity, but a reciprocal trig ratio that we need to use too. So this is another thing we'll need to use. So it's a reciprocal of the sine ratio. And of course, there's a reciprocal of cos and tan. So the reciprocal ratio to cos theta, so cos theta is adjacent over hypotenuse, or now we say x over r. But it also has a reciprocal ratio, and its reciprocal ratio, is called secant. And secant is 1 over cos theta. So it's the reciprocal ratio. So it's like you took cos and you flipped it around, because normally it's cos over 1, right? But now we did 1 over cos. So therefore it's like, hypotenuse over adjacent, or r over x. So this guy right here is a reciprocal trig ratio, and we'll need it to solve some trig identities too. Okay, final one is tangent. So I should just write this too. This is secant. So we got cosecant, secant, and we know tan theta is equal to opposite over adjacent, which is y over x, and its reciprocal trig ratio is called cotangent. So cotangent theta is equal to 1 over tan theta. So I'll just write this. We call this guy cotangent. And it's the reciprocal ratio to tan theta. So it equals adjacent over opposite, or x over y. And one important thing about the cotangent ratio is, this is getting crazy, but remember how we learned that tan theta is actually equal to sine theta over cos theta? That was our quotient identity. Well, since cotangent is the opposite of tan, like the reciprocal of tan, then we know that cotangent would actually be equal to cos theta over sine theta. So these are like, that's your quotient identity. And this identity could be used also because we know that cotangent theta is equal to 1 over tan theta. Okay, so basically, to sum up what we got here, here's all your identities that you will need to prove other identities. So you've got the quotient one, which is tan theta equals sine theta over cos theta. You've got cotangent theta is equal to cos theta over sine theta. You've got all your reciprocal identities. So cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cos theta. Cotangent theta is equal to 1 over tan theta. And then you've got your Pythagorean identity. Sine squared theta plus cos squared theta equals 1. So if you want to give these guys names, these are your quotient identities. The next three are your reciprocal identities, or trig ratios. I don't know what you would call those, reciprocal. And this last one is your Pythagorean identity. So all of these things I would give you on a test. Like I would give you these formulas. I don't know if I'd give you the reciprocal ones, but I would definitely give you quotient and Pythagorean. Although it's kind of important to just remember them because you'll use them all the time and you have to constantly like look them up. It'll take forever. And I won't be giving you the variations. So just knowing that sine theta is also equal to 1 minus cos theta, cos squared theta, and cos squared theta is equal to 1 minus sine squared theta. That's handy to know too. So this whole page is like what you're going to use to solve other problems. So let me just give you an example of what's coming. I'm going to do a lesson on this tomorrow. This is like the longest video. Okay, so let's say you wanted to prove this identity. So you want to prove that 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, so you want to prove this ratio. So we separate it into two sides. We've got the left side of our identity and we've got the right side of our identity. So usually you pick a side to work with, but you can also work with both sides. So I'm going to pick the left side first and see how far that gets me, because it's nice to pick the most complicated side. Okay, so the left side is 1 plus cotangent squared theta. So I'm going to switch, I'm going to scroll up here, that cotangent theta is equal to cos theta over sine theta. So if I were to square both sides of that, I can also say that cotangent squared theta is equal to cos squared theta over sine squared theta. Right? I can say that. I'll just square both sides. Okay. So 1 plus, so I'm going to change that to be cos squared, I guess I don't need a bracket there. Okay, one sec. I'm going to change that to be cos squared theta over sine squared theta. Okay. Oh, Canada's going to play soon. Okay, so then maybe I'd want to try to put these equations together. So maybe I'll want to make them have a common denominator. So I'm going to multiply this first fraction by sine squared theta and this top one by sine squared theta. So I'm just trying to make a common denominator. So I've got sine squared theta over sine squared theta plus cos squared theta over sine squared theta. Now that they have the same denominator, I can add the tops. So the tops become sine squared theta plus cos squared theta divided by sine squared theta. Okay, so now using an identity, I'm noticing that the top of my fraction here, sine squared plus cos squared, is actually the Pythagorean identity. So I'm noticing that sine squared theta plus cos squared theta is equal to 1. So I can replace my numerator with 1 over sine squared theta. I'm getting super close because I'm trying to prove that the right side is cosecant squared theta, which I've basically just done. Because using my reciprocal identities, 1 over sine squared theta is actually cosecant squared theta. Because since I know that cosecant theta is equal to 1 over sine theta, if I just squared both sides of that, it's just going to equal cosecant squared theta. So now that I've actually made the left side of my equation equal the right side of my equation, I've proved, so that equals the right side. So therefore, 1 plus cotangent squared theta is equal to cosecant squared theta. Because the left side equals the right side. Okay, I better end this video, but that's just a sample of what trig identities are, where you have to prove that the left side is equal to the right side using all of these identities, and you're just like subbing them into equations. It's kind of crazy, but there you go.